Welcome to lecture 8 in the R module of the course Data Science for Engineers. In the previous lectures, we have seen how to create functions, how to execute them, but we have limited ourselves to the single output. In this lecture, we are going to see functions with multiple inputs and multiple outputs, which we call MIMO, how to source and call those functions. We'll also see about inline functions, how to loop over objects using the commands apply, lapply and tapply. Let us see the functions with multiple input and multiple outputs. The functions in R takes multiple input objects but return only one object as output. This is, however, not a limitation because you can create a list of all the outputs which you want to create, and once the list is written out, you can access the individual elements of the list and get the answers which you want. Let us consider this example. I want to create a function wall cylinder underscore MIMO which takes diameter and height of the cylinder and returns volume and surface area. Since R can return only one object, what I have to do is I have to create one object which is a list that contains volume and surface area and return the list. Let us see how we can do that in the next slide. So you need to first create an R file, which we have seen several times. You can create an R script using a plus button or from the file tab. Once you have opened an R script, this is the piece of code that does what we need. We want to name the function as wall cylinder underscore MIMO because it's a multiple input and multiple output. And this function takes in arguments, diameter and length. Earlier we have calculated only volume, and now we want to calculate the surface area also, which is given by pi times diameter times length. Since R returns only one object, first I need to create an object called result, which is a list of volume and surface area. I am naming the volume as volume and surface area as surface area. I will calculate this result and ask the function to return one object, the result, which contains both volume and surface area. Once you write the function, you need to load the function to call it. Loading can be done using the source button. Once you source it, you are ready to call a function. You can call the function once you load the function. So I am calling this function result is equal to wall cylinder underscore MIMO, and I am passing 10 and 5 as my arguments. This result will contain two elements. The first element volume will contain volume. The second element surface area will contain surface area. Once this object result is given out by the function, I can access individual elements by using the techniques what we have taught in the lists lecture. Sometimes creating an R script file, loading it, executing it is a lot of work when you want to just create very small functions such as the ones as shown here. X square plus 4x plus 4, I want to evaluate this expression for different x's. So having a function file and then loading it, invoking it is a lot of work. So what we can use in this kind of situations is an inline functions. To create an inline function, you have to use the function command with the argument x and then the expression of the function. Once you create this, you can call this in the command prompt itself. Function of 1 takes the value of 1 as an argument and then evaluates this expression. 1 square is 1 plus 4 times 1 is 4, 1 plus 4 is 5 and plus 4, 9. Similarly, you can get the outputs for different arguments which are passed, which are shown in the screen. So now we move on to looping over objects. There are few looping functions that are pretty useful when working interactively on a command line. Few examples are apply, lapply, tapply and so on. Let us see what each of these functions does. Apply function applies a function over the margins of an array or matrix. lapply function applies a function over a list or a vector. tapply function applies a function over a ragged array. and mapply is a multivariate version of lapply. We will see examples for each of this in the coming slides. Here is an example for apply function. What apply function does is applies a given function over margins of a given array. When we say margins here, this refers to the dimension of an array along which the function need to be applied. Let us create a matrix A with the elements 1 to 9, which is of 3 by 3 size. You can do that using this command, and when you print A, you can see this. Now I want to evaluate the sums across the rows and the sums across the columns. You can use the apply function to do so. The syntax for this is take the matrix A and then apply this apply function across the rows of matrix A, and the function you need to apply is sum. So now what it does is it will sum up this first row 7 plus 4 plus 1, that is 12, sum up the elements in the second row and prints here, and sum up the elements in the third row and prints the output. You can do the same for the columns by specifying the margin as 2, which says apply the sum function on A across the margin 2, which is the columns. This command will print the sums of the elements in the columns as 3 plus 2 plus 1 is 6, and so on. Next we move on to lapply function. Lapply function is used to apply a function over a list. So that's why you have L here. Lapply will always return a list which is of the same length as the input list. The syntax for the lapply is as follows. You have to use the command lapply and the list on which the function has to be applied and the function which has to be applied on the list. Let us illustrate this lapply using example here. Create a matrix A which is having the elements from 1 to 9, which is of size 3 by 3, and create a matrix B which are having the elements 10 to 18 and which is of size 3 by 3. Now I am creating a list of matrices A and B using the list command. I want to evaluate the determinant of the matrices and then store them in a list. One way to do is calculate determinant of A, calculate determinant of B, and calculate and make them as a list. You can do easily the same operation using the lapply function, which is shown here. I want to name that variable as determinant. I use the function lapply. I want to apply the determinant function on my list. When I do that, it will calculate the determinant of A and then store it in the element 1. It will calculate the determinant of B and store it in the element 2 of a list. Now let us move on to the mapply. Mapply is a multivariate version of lapply. What it does is this function can be applied on several lists simultaneously. The syntax is mapply, the function you need to apply on list 1 and list 2 together. So we have seen our function wall cylinder. Now let us suppose I want to calculate the volume for different diameters and different lengths which are having as a list here. I have a list of diameters and I have a list of lengths. I want to evaluate the volume for each individual pairs of dia and length. You can individually take this length and dia and execute the same function, but it is so tedious. mapply helps in simplifying this job for us. You need to create one variable wall and then apply the function mapply on the wall cylinder function, because this is the function first, we need to apply the function, and then the list 1 and list 2. We have two lists, dia and length, and what it does is it will take a pair and then calculate the volume, and it will return the volumes for two lists of dia and length that are given. Next we move on to the tapply function. Tapply is used to apply a function over a subset of vectors given by combination of factors. The syntax for that is tapply, a vector, factors, and the function you need to apply. So to illustrate tapply, let us use this example. I am creating a vector called id using this concatenation operator, which contains 4 1s, 3 2s, and 2 3s. And I am also creating another vector which is having the values again a concatenation which are having the elements 1 to 9. Now if I want to add the values which are having the same IDs, tapply function can help me. So what I need to do is tapply, I want to add these values. The adding is given here as a function which is sum according to the ID they belong to. What it does is it will take the elements corresponding to one ID, for example 4 ones, and the values 1, 2, 3, 4 and sums them up. 4 plus 3 7 and plus 2 9 and 1. So sum is 10. Similarly, it will take the values corresponding to the ID 2 and then sum it up, and values corresponding to the ID 3 and sum it up, so that it will print the output which are indicating the sums of the elements of category 1, category 2 and category 3. The tapply prints the output as the sums of the elements which are having ID 1, ID 2 and ID 3. In this lecture we have seen how to write functions which takes multiple inputs and multiple outputs. We have seen inline functions, and we have also seen some functions that are useful to loop over the objects. In the next lecture we are going to discuss about the control structures in R. Thank you.